Okay, we're going to do some graphing of quadratics or parabolas. So a parabola or a quadratic in standard form, quadratic is where the highest power of x is equal to 2. So something like y equals ax squared plus bx plus c. So that's a quadratic in standard form. It takes on a shape if a is positive. It's a graph that will look like a U, look like this. If a is negative, then the parabola flips over like this. Okay, so it's just the general shape of what the parabola will look like, either a being positive or a being negative. The vertex is the tip of the parabola. Okay, so the tip of the parabola is the vertex. So when you think about like in if a is positive, it's that very minimum value. If a is negative, then it's that maximum of the parabola. So like if we were to kind of say, okay, where is the vertex? The vertex on this one would be right here. The vertex on this one would be right there. Now we can find the vertex. The equation for finding the vertex kind of takes on VRTEX. It takes on making sure that you know that you're in standard form. Remember, we talked about standard form in the first unit where it was decreasing powers of x. So if you have these values a, b, and c, which are just numbers, right? You know, a, comma, b, and c, all just numbers. Okay, those are just numbers. So when we're looking for the vertex is x is equal to the opposite of b divided by 2a, whatever b and 2a are. So we're going to use that in a second. We'll graph the vertex and kind of go and figure out what it looks like and how we deal with it. So that's the vertex. The zeros or roots, if you're looking for the zeros or the roots, those are places where the graph crosses the x-axis. So if you know a parabola, if you have axes with them, I haven't drawn them with axes yet, but if you have a parabola where you cross here, these two things right there are the roots or zeros of that parabola. This value up here, that's going to be the vertex. So when you're trying to graph a parabola, you really need those pieces. Those are kind of the most important pieces that you could have. Those will shape the parabola for you. You know, it basically looks like a U, either upside down or right side up, but the vertex is that tip of the parabola, and the roots are where the graph of the parabola crosses the x-axis. So if we're doing a problem, something like this, this is the kind of problem you'll have to do in Delta Math today. So here's the first example. Graph the equation on the accompanied set of axes. You must plot 5 points, including the roots and the vertex. Using the graph, determine the roots of the equation. So we're gonna go ahead and graph this, and I'll show you a couple of ways to graph it. One way to graph it, and just knowing where things are, you know that the vertex is when x is equal to the opposite of b divided by 2a. Well, you think about like this problem, a is equal to 1, b is equal to -2, and c is equal to -3, because then I just pulled those values from the equation. You know, the value right in front of the x squared is 1, the value in front of x is -2, and the constant is -3. So those are the values of a, b, and c. So if we wanted to know what the vertex is on this problem, the vertex is when x is equal to the opposite of b, since b is -2, is 2, divided by 2 times a, and a is 1. So in the end, that's the value of the vertex. Now, if you need to find the y value, it's when x is equal to 1. So just put a 1 in for x, and you could get the y value, and that would generate that point that we always kind of talk about when we're graphing. That's an important piece. It was important when we were dealing with piecewise functions. It's important now. So you got 1 squared minus 2 minus 3. You do the arithmetic on this. You got 1 minus 2 minus 3. So you got -5 plus 1, -4. What that means is the vertex is at 1, -4. You notice that this one opens up because a is positive. So this one opens up. So what we know right away is we know that 1, -4, there's our vertex. So our parabola is going to take on that shape. Now, if you're graphing this in Delta Math, it says, okay, you got to include, you must plot 5 points, including the vertex, the roots and the vertex. Now the roots again are when the equation, when the graph looks like this. It's also when y equals 0 for the equation. Okay, so it's also when y equals 0, because remember, when y equals 0, you'd be right there on that x-axis. So if we wanted to find the zeros of this, or the roots of this, we would want to know what values make this equation true. When is y equal to 0? Well, if you remember back from the first thing we did, one of the first 2 assignments we did, is we could factor this equation. If we factor this equation, this thing factors into x minus 3 times x plus 1. Way back when we factored it, when we undid FOIL. And you could do the box method on this, or you could do whatever method you thought about with this. I would encourage you not to use photomath, because photomath doesn't really stretch your brain. It just basically gives you an answer for you, and that's not going to help you in the long run. But if you think about this, the x values that make this true, the x values that make this true are x equals 3 and x equals -1. Those are the 2 values. Those are the 2 roots of this equation. Okay, because you think about it, if x equals 3, you'd have 0 is equal to 3 minus 3 times 3 plus 1. So 0 is equal to 0 times 4, which, 0 is equal to 0. You didn't have to do that, but that just shows you that that's one of those roots. So the two roots are 3 and negative 1. So we can go up to here and go, okay, negative 1 is one of the roots, crosses right there. 3 is another root, crosses right there. Tells us we need to, what it looks like. Tells us we need to have, in this problem, that we need to plot 5 points. So another point you could find is you could say, well, if x equals 0, y would equal 0 squared minus 2 times 0 minus 3. So y is equal to negative 3. So we have another point, 0 comma negative 3. And you know that if this is a point, because it's a parabola, so is that. And then when you do that on Delta Math, it'll draw the rest of it. So you'll have to do some problems like that. Go back to those and check those out and see what you can come up with, or see how you can do on those. You're also going to have to do some word problems, and we're going to use Desmos graphing calculator for these word problems. And so this problem, a company sells widgets, whatever the widgets are. The amount of profit, y, so y is the profit. Okay, I got that from right there, the amount of profit, y, made by the company is related to the selling price for each widget. So the selling price for each widget, x is the selling price. It's given by the equation. Using this equation, find out what price the widgets would be sold for to the nearest cent in order to earn the maximum profit. So when you think about that, so when you think about transferring this question, we want to know what is x when y is a maximum. Well, we know that if we draw this parabola, think about this, since a is equal to negative 9, this parabola is going to have to open down like this. So we know that that's the way it's going to be. So what we're going to do is we're going to go to Desmos. If you just type in desmos.com, you'll get this. And if I just hit graphing calculator, I can get a graphing calculator on this. And right in here, it's just like any graphing calculator. I can type in negative 9 x, and then I want to raise it to the second power. So it already drew a parabola for me. See that? You can see that it already drew a parabola. Plus 700. Okay, so now it went outside of my window. And it's 700x minus 6,005. And if you look at it, you go, well, shoot, it doesn't show me anything over here. If you use the minus arrow, or if you have a rolling thing on your mouse, you can get the whole parabola if you zoom out far enough. And you look here and you go, oh my gosh, this looks terrible. Well, we could change this a little bit if we wanted to. Notice that way down here, our two roots right here were between 70 and 80 and right about 10. So what I can do is I can hit this, this little wrench here, and it changes my graphing settings. Notice that my maximum, I could drag this all the way up, and I'm just dragging this thing, but my maximum is going to be way up there at the top. Well, what I'm going to do is I'm going to change my settings a little bit. I'm going to go to my settings, and my x minimum, I'm going to make it So I'm going to go in here and make my x minimum 0, and I'm going to make my x maximum, I'm going to make it 80, because that's, and then I'm going to make it go up by tens, but it doesn't really matter. It already shows that it's going up by tens. Now I want to see the whole graph. I know that I'm selling widgets, so I know that my lowest needs to be 0. But let's look at my highest, and how can I get so they see this red line? You could just try some different things. What if I put 100? That doesn't work. What if I put 1,000? Oh, I'm starting to see it. What if I put 10,000? And suddenly I see exactly what my parabola looks like. Now, if I want to see the bottom end, I could also just put in -10, and then suddenly I would get this. Now look at that. Now I scroll out and there's my parabola. Now if I want to know the maximum selling price, so remember back here, my maximum, I'm supposed to figure out on this what is the maximum profit. So I'm really looking for that vertex. I'm really looking for the vertex of this parabola. So if I go back to Desmos and I click up here, what I get is I get the vertex. If you click just at the top of this, you'll get other points too. But if you click at the top, you'll get the vertex. I can also click my 2 zeros as well, because those are the 3 most important parts of a parabola. So what I found out is that my vertex is when x is equal to 38.889 and y was equal to 7606.11. So if I go back to my question, it says, using the equation, find out what price the widget should be sold for to the nearest cent for the company to make a maximum profit. Well, that's my x value that I'm looking for right there. That's what value I'm looking for, so I should sell these things for $38.89 is what I should sell these widgets for. So let's look at one more example. One more example, a rocket is launched from a tower. The height of the rocket is y in feet, so let's start writing some of those variables down to figure out what we're going to need to be asked. So let me highlight that in red. The height of the rocket is y in feet, so y is the height of the rocket. Is related to the time, x in seconds. So x is the time in seconds, and the height of the rocket, remember that was in feet. It's given by this equation. So let's see what they're asking us to do. Using the equation, find the time. Okay, so we're supposed to find the time the rocket will hit the ground to the nearest hundredth of a second. Okay, when is the rocket going to hit the ground? Well, if you think about what's going to happen, so we're really asked for when the rocket hit the ground. So when is the x 0? So what I mean by that is you think about what's going to happen here. The rocket is going to be launched from here. It's going to go up. It's going to reach a maximum height. It's going to go back down and hit the ground here. Starts on the ground. Ends on the ground. If we want to know the vertex, the highest the rocket would go, that would be the highest the rocket would go. We want to know what time. Remember, time is over here, and feet is here because this is x, and this is y, and that's what our variables are. So if we want to know when the rocket is going to hit, the time the rocket's going to hit the ground, that's what we want to know. That's our answer. That's the value we're trying to find. We can find that value using Desmos again. Okay, So remember, we got that negative 16. It's going to make a parabola. So go back to Desmos, and you can just erase this equation. And we're going to type negative 16 x squared. Oops, I have to make it a squared. And it starts to draw it. There's my parabola. Plus 119x plus 57. And there's my parabola. Now I'm going to zoom in a little bit to kind of get an idea of what this parabola looks like and see how this rocket is. But there's my rocket. My rocket starts, looks like it's starting from a launching pad. Notice that it's a little higher than if this is the height. If you think about this being the height right up here, the rocket goes up, reaches a maximum height right there. There's the maximum height, 278, and then the rocket hits the ground way over there. And so if the rocket hits the ground at this 7.889, 0, if we go back, that's our answer, right? I mean, that's that point right there. So when we're asked this question, to the nearest hundredth of a second, so hundredth of a second is 2 decimal places. So the nearest hundredth of a second, our answer is when t is equal to 7.89 seconds. So that's the answer. Good luck on your assignment. Let me know if you have questions.